All right, guys, I want to move on to this type of equation, okay? These are obviously solving equations with rational exponents. They are another type of equation that once we do one step, they should default themselves down to something we're familiar with. Okay, they should default them, in all of these, they default down to a quadratic that we can solve pretty easily, okay? There's a couple things, though, that I think is important to talk about before we just start going through the process, and that's how they can present the question to you, okay? You guys are familiar, hopefully, from Algebra 2, that, like, if I have the square root of x, do you know how to rewrite that with exponents? X to the, anybody? X to the 1/2, good, okay? And that 1 comes from the exponent that is attached to the variable there, and then the 2 is actually the index of the radical, okay? So we can generalize that by saying, like, the nth root of, let's say, a to the m is equal to a to the m over n, right? Does that make sense? Okay, it's following the same pattern that we saw here with x to the 1/2. Now, that being said, then I should be able to come down here and write this equation a little bit different. I should be able to rewrite this as the square root of x cubed minus 10 times the square root of x. Okay. Now this here, what's a negative exponent? If I had like x to the negative 2, how would I rewrite that? Do we like negative exponents? No. So we take wherever it's at, and it goes across the division, right? Okay. So this is going to go into 1 over x squared. So here, and remember the thing that the exponent is attached to is just the object that's directly behind, so just the x here. I would rewrite this as plus 25 over radical x. Does that make sense? Okay. And then that's equal to 0. So that is an alternative way that they could present you the question in a homework or test or quiz format. We're going to see our examples kind of circumvent that step, that blue step, and you're just see what we see here written in black. But I need you to know that there are varying formats that you might be presented with, okay? And you know, we'll do 2, 3, 4 of these in class, and you might get one in your homework that is written in like the blue format. And you're like, well, we never did this in class. Well, we have to rely on our previous knowledge of Algebra 2, Algebra 1, to be able to reformat an equation to something that maybe is familiar to us through examples. One thing right there, I automatically know when I'm done, there is one particular value that will not work here. What value? And we know that x's can't be negative because you can't take square roots of negative, right? What is the other issue that we have? 0. If x was 0, and that 25 times x to the negative 1/2, or in better version, 25 over square root of x, if x was 0, we have square root of 0, right? Which you can do that. You get 0. But then that last term would be 25 divided by 0, and that's undefined, right? So it tells us x is not defined for this equation. It's not part of the domain of that left-hand side, so it cannot be a solution, okay? Keep that in mind as we go through this process. So when you see something like this, my suggestion is to, if there are negative exponents, you find the largest negative exponent and you try to factor it out, okay? If you can't remember certain like tools like that, certain structures, factoring the largest negative exponent, and you try this one, you're going to get it, you're going to be able to do it, but it's going to leave you with another equation that kind of is as difficult as the current one, okay? If you try then, that didn't work, so then you try the next one. If it leaves you with something as difficult as the current, then it didn't work, and you try the next one. Does that make sense? Okay. Now, I would hate for you to, do like a trial and error of what needs to be factored out, like 3 times, 4 times, 5 times in a problem. So, like, that decision of choosing the largest negative exponent might expedite that a little bit, but I'm not saying that's set in stone. There might be times where that doesn't necessarily work. But that's what we're going to do for these couple examples today, and I think it should work mostly for your homework. Okay, so I'm going to factor out an x to the negative 1/2. Okay, when I factor, what's factoring a fancy word for? Undistributing. Okay, so what's distribute mean? Multiply. So undistributing would be unmultiplying, which is dividing. Okay, so to figure out what I'm left with, I'm going to divide each one of these by x to the negative 1/2. And that requires us to lean a little bit more on our laws of exponents that we learned from Algebra 1 and Algebra 2. Do you remember that if I had x to the m over x to the n, how I go about and rewriting that as x to the what? M minus n. Okay. Last class we kind of talked about this. If x to the m was like x to the 4th, and x to the n was x to the 3rd, a lot of us just say, oh, cancel, cancel. There's 4 up here, there's 3 down here. It really means this. And then we can obviously cancel those 3 with those 3 and left with just x, right? Okay. But when I'm doing fractions, when my exponents are fractions, I'm not multiplying whole quantities of x, right? Okay. Or integer amounts of x. So I'm not sure how they cancel like that. So then it becomes imperative that I understand that. Okay. I know that, and I've had students that have done this in Algebra 1, Algebra 2, when you learn this law, yeah, you learn it great, fine, whatever, but you always did things this way and never really took time to learn this. Does that make sense? And now if that was something that we did, you got to ask yourself, am I that person? Because now this technique runs you into a roadblock and you don't have the ability to work in this problem. Does that make sense? They give us laws like this because inevitably the shortcuts like this are going to run out. Okay? So when I do that subtraction, I'm going to go 3/2 minus negative 1/2. What's 3/2 minus negative 1/2? 4/2, which reduces to 2. So we get x squared. It's going to be then minus 10. That's x to the 1/2 minus negative 1/2. So it'd be x to the 1st. And then here in this last one, we chose a good option here for what we factored out, and those are that's a 1-to-1 cancellation, right? They're the same thing. So it leaves me within just plus 25 is equal to 0, right? So we can factor that. So that's the idea, that one step, and that one step factoring out the largest negative exponent, that one step generates something now that we're comfortable with. We should be comfortable with that thing in the parentheses. And that thing in the parentheses factors down to what? X minus 5, x minus 5. So that tells us that one solution is 5, right? Now, I've also got this thing here. This is still a factor, x to the 1/2, negative 1/2. If I let that equal 0, okay, there's a couple of things here I think you can do to kind of logically think this through. One of them is to rewrite it this way. Okay, and you might argue, well, now I got to multiply both sides by radical x. But we would never really do that. We would never multiply both sides here by an algebraic term, because you guys ever heard the phrase that we lose a root by doing that? we lose a root. Okay, we lose by doing something like that, by multiplying 0 by our variable term, we end up potentially missing solutions. Okay, so we don't want to do that. Okay, so what we start doing is we think about values of x that we're able to put in there and see, are any of those going to give me 0? Kind of like a trial and error type thing, but it shouldn't take too long to recognize a pattern here. If I plug in x to be 1, I get 1 over 1. Does that ever equal 0? Well, if I try x to be, let's think like 1/2. Well, actually, let's go 1/4. Okay? If I put 1/4 in there for x, what's the square root of 1/4? 1/2. What's 1 divided by 1/2 then? 2. Does 2 equal 0? No. Okay? If I try like 1/9, I get 1/3, right? In here. So it'd be 1 divided by 1/3, which would be 3, right? Okay? So as I went from 1/4 to 1/9, next one I would try is like 1/16. I'm just trying to do mental math here, choosing values of mental math that are a little bit easier. But that would give me 4, right? Does 4 equal 0? No, but what are you seeing here as I choose a number between 1 and 0, because 1/4, 1/9, 1/16, 1/25, those are getting closer to 0, right? As my x value. This quotient then is increasing from 2 to 3 to 4 to 5 to 6, so it's going to keep going on that pattern. So the closer I get, the closer this number gets to 0, okay, the larger this left-hand side gets. Now, I can't choose 0, right? I'm not allowed to choose 0 because I'll have 1 divided by 0, okay? But the closer I get to 0, this number grows essentially towards infinity. Let's try numbers that are bigger than 1. If I try like 4, I get 1/2, right? Does that equal 0? What if I try 9? I get 1/9. Does that equal 0? Now, what if I try like 1/900? Or put 900 in there, and I get 1 over 300, right? Or 30. Yeah, sorry, 1 over 30. 1 over 30, is that 0? No, okay? Now, you can maybe argue, well, you are, and this is the asymptote idea, eventually, as x goes to infinity, I have 1 divided by a very, 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 very large number, and 1 divided by a very, 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 very large number is close to 0, but it's not 0, right? Okay, so you're never going to get it. So this is never going to produce a solution. Does that make sense, everybody? That's kind of the argument that I was trying to make there with that. So our only solution is 5. It shows up 2 times. When I look at the graph, what does it mean when I have 2 solutions or one value that is showing up as 2 solutions? It's going to be tangent. Okay, so let's take a quick peek at this graph. Do it in here first. We'll go x to the, be careful when you're using Desmos and you have rational exponents that you put those exponents in parentheses. This is why I like Desmos over like your TI-83 or 84, because this is a nightmare to type in your TI-83, 84. It looks ugly, and you're not always confident whether you've done it correctly. But this looks exactly like it was presented to me, right? Okay, so if I try x to be 0, you see that it's undefined. And that's usually the number one error. I know we didn't come up with a value here, but that's usually the number one error, that people see this and set it equal to 0. Oh, x must be 0, because when I had something like maybe previous questions in the past, like we had x squared something there equals 0, we say, well, x squared equals 0, so x must be 0, right? Okay. People make the same argument with this type of thing, but by checking, you would, if you did accidentally make that argument, your check would eliminate that for you, because of the undefined concept. Now, if I try 5, does 5 evaluate to give me 0? Okay. If we graph this thing, Control C, Control V, go to home. That is our graph. Okay. The reason x cannot be 0, I put that green curve in there, which is just the y-axis. Okay, and I come up here. Now, they look like they're going to cross, but I should be able to, no matter where I'm at on the y-axis, up to 1,200 here, or 10, 100,000. I should be able to zoom in far enough, and there is separation between the two, right? Okay, because you're never allowed to have 0. We shown here when x was 0 that it was undefined. Basically, when I'm showing, when I put x to be 0 in there, I'm looking for instance, when I plug in 5. Where's my backspace? When I plug in 5, that means when I plug in 5 into my graph, or look at my graph, the y value that's coming back when x is 5 is 0, right? If I were to plug in just some random number like 9, okay? What that means, when I look at x would be a 9 on the x-axis, the y value that it's spitting back is 5.333. That's the ordered pair that's on that curve then. Well, because 0 gives me undefined, there is never a place that 0 will be graphed with something on that curve. Does that make sense? Okay. So that's I personally believe that these are sometimes maybe the harder types of questions that we'll see for a long time. I'm not saying it's the hardest question in the class that we'll see, but these types of equations, because we don't, one, they're few and far in between, so we don't see a whole lot of them, so our exposure and experience with them is limited. But two, just all the different notation that happens with inside them, just the sight of them sometimes just scare people and they shut down right away. Okay, but if we can transform them a little bit with our notation, do a factoring technique, see what happens, I think that'll be a benefit to us. Okay, let me see something real quick by hand of that. So if we were to take, obviously we said we want to factor out the largest negative exponent. I'm going to contradict that. Let's just factor out a 1/2. Okay, so if I factor out an x to the 1/2, that first term is going to be just 1, correct? Okay. Factor out an x to the 1/2, so now I'll have negative 1/2 minus 1/2, which will be minus x to the negative first. And then here, I will have negative 3/2 minus negative 1/2. So it'll be negative 3/2 plus 1/2, which is negative 1, right? Okay. So we get minus 6x to the negative 1. We've got some like terms here we can kind of mess around with, but we still have something to the negative exponent, right? It's not really cleaner than what we started with, all right? And if we tried maybe factoring the negative 1/2 out, we would see that what is left over here is not a convenient thing to deal with, okay? So then that would eventually get us, our last option would be the negative 3/2, okay? So by doing something like that, by doing like similar questions over and over and again, and then recognize, okay, well, which one of those exponents in each of those examples leaves us with something that we can factor, something that we're familiar with, you'll find out that it's usually the one that factored out was the one that was the largest negative exponent, okay, in questions that are similar structure. So let's do that. Let's factor out an x to the negative 3/2. So I get 1/2 minus negative 3/2. So it gives me 4/2, right? So I get x squared. I get negative 1/2 minus negative 3/2. So it's negative 1/2 plus 3/2. So it should give me minus 1x, right? And then the last one, these cancel 1 to 1, leaves me minus 6. You see how that is much cleaner than alternative options. So that factors x minus 3, x plus 2. So this thing here, so x to the negative 3 halves equals 0, x minus 3 equals 0, x equals negative 2. I should probably say x plus 2 equals 0. And then we get our solutions. X is 3, x is negative 2, and here x, what is this going to be? It'd be 1 over the square root of x to the third equals 0. And that's the same idea as what we did previously with when it was 1 over radical x. That's not going to produce anything. I can't let x be 0 because I get 1 divided by 0. And then anything that I choose for x will never evaluate. I always have a numerical quantity on the bottom there. And 1 divided by anything is never going to be 0. Okay? So that doesn't give me a solution. So what are my solutions? Three and negative 2. Okay, so you might initially think that, because initially looking at this problem, it doesn't look like there would be any issue with that negative 2, right? Good, so x to the 1/2 is radical x, right? Minus 1 over, I'll write it this way, radical x, minus then 6 over that, correct? And the only way that I can evaluate the left-hand side of this is if each one of those terms evaluates individually, right? Meaning that I need a number to be kicked back to me when I plug in an x. When I plug in negative 2, does the square root of negative 2 kick back an output? No. And not from the real number line, right? And that's what we're solving all these on. We're solving all of these on the real number line. So negative 2 kicks back something imaginary. So negative 2 is not part of this function's domain. So it's not going to be a value that I can use as a solution. Okay? So negative 2 does not work. My only solution is 3. Does that make sense? Okay. Let's jump down to this example 4. This is going to help us, this type of question here is going to help us get into what I want to focus on predominantly with the next set of examples. Okay. Now we could probably factor something out here. We'll probably factor out r 1/4, see what happens. But what I want to do here is I want to recognize the type of format this thing is in. Let's write this in terms of exponents. So if I rewrite this as be x to the 1/2 minus 3, x to the 1/4 minus 4 equals 0, right? Okay. What's the relationship between that 1/4 and that 1/2? How many 1/4 are inside 1/2? 2, right? So there's a 2-to-1 relationship with those exponents. Okay, that's a key thing to remember, because let's look at this. Anything that is quadratic, like ax squared plus bx plus c, what's the relationship between that exponent there and that exponent there? Okay, so I want to do a comparison through division instead of subtraction. So it's half, right? It's a 1-to-2 or 2-to-1 relationship. Okay. What if I did so? So that's quadratic. Anything like that's quadratic going to yield a parabola, right? Okay. I'm going to write something here. I'm going to say quadratic in form. Okay. Not meaning that's going to yield a parabola, but the equation itself be something like this, where now what's the relationship between that exponent and that exponent? Still a 1-to-2 relationship, right? Okay. What do we see here? Is this a 1 to 2 relationship? Okay, so this is quadratic in form only. Okay, if I were to graph that thing, it's not going to give me a parabola. Okay, but it's quadratic in form. And because we can recognize that, we can use kind of a strategy or game here to make things easier for ourselves. Thank you very much. So we're going to redefine our terms. Okay, you're going to come down. When you recognize that this is of quadratic form, you're going to let u equal. Now you only choose the variable component of your middle term. So I'm going to let u equal x, excuse me, to the 1/4. I use u because in calculus you're going to use u. Okay, so I'm going to get you used to it. WebAssign, for some reason, uses w, and they use a capital W. So just be cognizant of that when you're doing your homework, and they ask you to like show work. They have like boxes throughout the entire problem to type stuff in, that you use the capital W that they're referencing. If I do that, what does u squared look like? X to the 1/4 squared, right? And what do you do? Laws of exponents, algebra 1. What do you do with these two? Multiply them. That gives me 2/4, right? Which is 1/2. So what I'm doing there with this last line is I'm just checking to make sure I chose the correct u term. Because u should allow me to replace this middle thing. Okay? I could let, like any problem I could do that with, right? The only time that this actually becomes beneficial is that when I square it, does it give me something to replace that term? Yes. Yes. So now, that right there, we just defined as u squared. So I got my -3. X to the 1/4, we let that be u. And then -4 is equal to 0. Do you see how that little game there made things a little bit easier? Okay, can we factor that? U -4, or u plus 1? So u is equal to 4, and u is equal to -1, right? Okay. Can I answer and this is the number one error that people make in WebAssign, is that they'll go right in and they'll say, well, the answer is 4 and -1. What am I trying to solve for? X. Okay, so now this next step is called back substituting. Abbreviate it. So u, we said, was x to the 1/4. So I'm just going to take that and back substitute it with what it was initially equal to. I'll do the same thing when I have my -1. Now, I'm going to, how do I solve for x here then? Raised to the 4th power, right? 4 raised to the 4th power is 256. I'll come over here, I'll raise this to the 4th power, and I'll get 1. Okay. Now, the only thing that we have to pay attention to here, because we raise things to the 4th power, which essentially means we squared things, right? When we square it, then we squared it twice. When we square things, we bring in potentially extraneous solutions, right? I'll plug in 1, and what's square root of 1? 1. -3 times what's the the 4th root of 1? 1. So we got 1 minus 3, which is -2, right? And then remove 4 again from it, that gives me -6, correct? Left-hand side is -6, right-hand side is 0. Is that a true or false statement? False. So x cannot be 1. Now, just to save time, if you plug 256 in there, Square root of 256. And we know what square root of 256 is? 16. Minus then 3 times the fourth root of 256, which is 4. So we got 16 minus 12 minus 4. Does that give me 0? Yes, it does. So 256 does work. But the idea, something that we started off with looking pretty foreign, looking pretty difficult, with one procedure, it gets down to something a little bit easier, okay, a little bit more comfortable with. Yes? Yes. Okay, so if we go back up to the example 3, if I rewrite this as x minus 5, x to the 1/2 plus 6 equals 0, that's x to the first, right? Okay, so it's a 2-to-1 relationship. So if I let u equal x to the 1/2, then u squared would equal x to the 1/2 squared, which would just be x to the first, right? So then substituting x to the first is u squared, minus 5, x to the 1/2 is now u, plus 6 equals 0, u minus 3, u minus 2, u is 3, u is 2, bring in my x to the 1/2, right? So that's, I'm going to bring it in this way to make things maybe seem a little bit simpler. So x would be 9 and 4. And I just got to check them. So 9 minus 15 plus 6, does that give me 0? 9 works. If I go 4 minus 10 plus 6, does that give me 0? So that works. Is that all right? Okay. So if you've got negative exponents, like in these examples we've shown, negative exponents, makes sense to factor them out. Okay. The largest negative exponent, and in hopes the remainder here, okay, this quote or this remaining factor here is quadratic, and we can factor that using our previous techniques. If you don't have those, see if you have a 1-to-2 relationship with your A and B terms exponents. They're a little bit easier to do. So these questions here are all the same type of structure. What's easier about this one is that we've got integer exponents, right, or whole number exponents, so it's a little bit cleaner. But can I let u equal x squared here? Okay. And then u squared would be x to the 4th, right? Remember, I always want it to be only the variable part. I get some people to say, let u be 4x squared. Well, then if I square that, I get 16x to the 4th, right? Okay. I don't have a 16x to the 4th that I can substitute in for in my original. So that's why we only let the variable part be our u term. Okay. There are situations that just depend on how these numbers out in front relate. You could let u be like maybe a 2x squared or a 3x squared if this term out here related well to it when I squared it. Okay. So essentially the highlighted things, if they are square roots of one another, then maybe that works. But I would not trust that technique. But now we can go u squared minus 4u plus 3 is 0. So u is 3 and u is 1, right? So then x squared is 3, x squared is 1. And now because I introduced the radical, right? I'm bringing the radical in here to solve for x. So when I do that, then it's a plus or minus. So we have 4 solutions there, right? What was the leading term of the equation? Degree 4, right? And those things should match up, like we've talked about in the past. Is that something we can do? All right. No new homework. Okay. I did send out an email last week about just a reminder, this is a college class. I know not everybody in here is getting it for college credit, but the rigor, the expectations, the outside work that you might have to do for extra examples, the extra research you might have to do is college level. Okay. Just sitting in class, not going to be sufficient to being extremely successful. Okay. I always use the argument, the effort that I used last year, if I don't change that effort in this class, because a year later, I'm going to have either the same grade as last year, but most likely worse. Does that make sense? Content gets more difficult, effort has to increase. Okay. Just keep those things in mind as we move forward.